Yes, today, of course, good evening to all. I'll give you a kind of an introduction about what is JEE Physics and how to prepare. I've sent you one primer or what you say, a write-up. Hope you've gone through that. Have you, children?
Yes, sir.
And in my class, of course, in every class, I expect that, but especially in physics class, you need to keep talking. And more you talk, more interesting I'll make it for you. It's not just dry kind of a problem solving from the day one without knowing the meaning of it. So the main thing I expect from you people is to keep speaking. All right. Okay. Let me see. Something happened with the video. Can you see my video? Because I'm recording it. Actually, I wanted that to be there. Something happened with
Yes, sir. Yes, sir. We can see the slide.
Okay. All right. No, not the slide, my face.
Yes, sir.
It's visible,
Yeah.
sir. It's visible.
Yeah, we can see it, sir. Yeah.
Okay, right. I told you I will be putting it on the YouTube. All right. Now, look. One of you please read it. Vasist?
Sure, sir.
Read whatever it is there.
Yeah. At the very beginning, let me make it very clear that there is nothing like JEE Physics or NEET Physics. It is just pure physics, physics for class 11th involved.
Right. Do you agree, children? Talk to me for a while.
Yes,
today.
sir.
Yes, sir.
Yes, sir.
Look, when Newton was framing his laws of physics, or when he wrote Principia, he was not writing for our Indian students who would prepare for IIT-JEE or whatever, isn't it? He was curious in understanding about nature. He wanted to express nature in a mathematical way, right?
Yes, sir.
The way physics is done nowadays, I always sometimes feel maybe Newton must be moving in his grave. Think, if he knew that Indian students are spoiling physics in a bad way. Why I say this? Because too much of commercialization has come into this. So people made books for everything: IP physics, CBSE physics, MSET physics, JEE physics, NEET physics. There are not so many physics subjects as such. I hope you are all aware of that. We'll be actually doing physics, which is done all over the world at this +2 level. But remember, because of that, because we do physics, it doesn't just help you succeed in exams here, board exams, and as well your entrance exams to engineering institutions, but it will as well help you later in engineering and sciences, in your studies of engineering and sciences. Nowadays, there is a problem. Even students who went to IITs, not all of them, but some of them at least, even with top ranks, have a trouble in adjusting to the whole atmosphere there, because they don't give you notes. They don't ask you to mug up. And you should have a habit of reading a textbook, which nowadays is becoming a rarity actually in the cross-commercialized IIT-JEE coaching. But remember, you need to do like this, whether you go to IIT, whether you go to NIT, whether you go to some other college, or the worst scenario, you go to local college, it doesn't matter. Ultimately, when you go to engineering, you should be standing on your own feet. That is, you should be able to do things for yourself, because once you go there, no one will take care of you individually. That's a big system. You are supposed to be grown-up children there, and you will be taking care of yourself. That will happen if your basics in maths and physics are strong. Even chemistry, of course, but what happens nowadays in engineering, chemistry is not done much. So your maths and physics have to be very, very strong. So what we do here has a bigger goal like that, to make your physics very strong for your future studies. But as compared to the board exam curriculum, we do a lot of problem solving in physics in the name of JEE preparation, IIT-JEE preparation. The difference is this. For the board exams, probably you might learn some question answers, subjective answers you prepare. And especially in this intermediate scenario, you just same questions keep coming back. So even if you did not visit your textbook, you can still score 95%. So the mandate for the board exam is very, very limited. Though there's a textbook, hardly people read the textbook. Here, apart from this board exam preparation, and apart from the problems you have in your textbooks, 11th and 12th CBSE or intermediate first and second year of Board of Intermediate, we do a very good problem solving and very tough problems we do. That actually makes the basics even stronger, children. Though we learn the basics in the beginning, after applying it only, the actual meaning of the basics will come very clear to us. So what we do extra, apart from doing the subject called physics, is to solve many problems in the name of IIT-JEE. And these problem solving will be at various levels like this. Okay. We'll go from easy to difficult. All right.
Sure.
Level 1. What's happening? This one single window is not happening today. Something happened. Okay. Board exam and state level entrance exams is what you mean by the level 1. They are almost formula oriented, one idea. Level 2, JEE main and NEET. NEET is for medical entrances, right? There are 60,000 seats in India, and there'll be some few lakhs of people writing for it, some 10 lakhs. Even that exam has become quite competitive, especially for physics. In the beginning, it was too tough, but nowadays they made it a little easier. But still, there are some problems in that. And even if it is not numerical problems, even the questions are slightly analytical there. So level 2, level 3 for JEE main. See, JEE main has come in level 2 and as well level 3. What do you mean by that? In the JEE main exam, I hope you all know about it. Do you? We'll come back to that some other time in a special presentation. JEE main actually is a qualifying exam for JEE Advanced, and as well a recruiting exam for NITs, National Institutes of Technologies, right? So this JEE main, some problems will be at level 2, some problems will be at level 3. That means some problems will be at JEE Advanced level also. But JEE Advanced is level 4 and Olympiad. So JEE Advanced level goes from level T to level 4. This particular thing should be really understood by you very clearly. There's nothing like a clear-cut line between the levels. That's why I was just writing it like that. Okay, this problem solving can be named as JEE Physics if you want to say so. But remember, you cannot solve problems by taking a problem book directly, unless you did a lot of it in 8th, 9th, 10th. And remember, all students cannot do that. Only very high IQ students, who are very small in number, especially talented students, they might do. It doesn't mean that others are bad. Try to understand it. So we don't solve problems directly. That's meaningless. That's unscientific. But I want you to recognize one important fact. The final goal of our physics teaching will be to be in a position to solve very good problems. The Olympiad level is the highest level. That, okay, if you're not writing for Olympiad, you're not bothered about it. But JEE Advanced level problems are not going to be very easy, but very exciting, very challenging. if you learn the whole thing in a proper way from 0 level, do the subject first, read a textbook first. Of course, if you don't read a textbook also, I'll take care of that requirement here. But remember, if you develop a habit of reading at least that Resnick and Halliday, life will be really easy, children. Whatever it is, say somebody can do only level 2, somebody can succeed in level 3 also, for example. But this thing, remember it. The basic ideas and concepts we learn have a universal value I put here. When I say universal value, it really covers a good number of areas of our what you call life. Your life as a student, your life as a researcher, your life as a career man or woman. In all these cases, the ideas and concepts we learn in physics are going to be useful, directly or indirectly. And more than that, the way you learn physics will help you to learn anything in a big way in future. That's a important contribution I'm going to make to your learning by teaching physics to you people. All right. Now, of course, you are free to interrupt me in the middle about especially the information part, JEE Main, JEE Advanced. If you have any question to ask, you can as well ask here. But those people who are not into problem solving and who think their physics is not good, who think their maths is not good, you need not have to worry. We'll go from easy to difficult. We don't start directly here. Do you follow? That assurance I'm giving it to you people. So just for the sake of learning, you learn, and the process will take you to whatever you want. But if you ever think that no, this process thing I don't believe in, or I don't even understand, just give me direct problem, all that, no, it won't work, because the problems are not easy. But ultimately, Suchita, what's your name? Full name?
Suhita, sir.
Suhita only. SUHI, right? Yeah.
Yes.
Yes. I want to tell you again and again, you should come to a position where you will solve 50% of the problems given to you in a particular day, in a particular time. What I mean to say is, say, for example, 2 hours time is given, some 20 numerical problems are given. If you should come to a situation where in the given time, you should be able to finish 10 correctly. So that is the goal I'm putting for you people. 20 out of 20 is not impossible, but as you keep doing, you'll go up to 15, 16 also. Within the given time, good problems, 20 or less than 20, say 16, 17, it keeps changing. Sorry, 2 hours, not 1 hour, 2 hours, yes, 2 hours, some 20 questions, around 20 questions. Out of that, 10, if you get correct, you're going to be a very, you're going to go to a good national level institute. And apart from that, it means that you understood your subject in a big way. All right? Right.
Yes, sir.
Well done. So how do we teach this JEE Physics, so-called JEE Physics now? So I made myself very clear to you. When you say JEE Physics, you should immediately think that, okay, fine, I'm going to solve problems. Not directly, of course, not that will throw problems on your head directly. I'll show you that method we do for that. First, the lesson will be done in an extensive way, starting from ground zero. I just gave some pyramid from somewhere, basic, special, advanced, superior, best. So some kind of that ground up approach will be followed. But remember, you have to be very, very attentive. If one word is spoken here, one idea is discussed here, one example problem is done here, that is done keeping your requirements for future in mind. So later when we do certain things which depend upon what we did previously, this should come to your mind automatically. Your mind should be able to retrieve that information it gathered some time ago. But remember, it doesn't happen just like that. If you remember it as a fact, it won't come. You cannot see, as you keep doing lessons in maths, physics, chemistry, and languages, and this lesson, that lesson, this problem, that problem, it will be a lot of what you call cluttering happens. So it's very difficult to clear the clutter and get your piece of information you wanted if you remembered it as a piece of information. But if you remembered it as an idea, if you understood it and you got a feeling that, yeah, it shouldn't have been otherwise, yes, it should be like this only, then it mind automatically connects properly in the neural connections. So when required, you'll be able to retrieve that information and apply it. Slowly, you keep applying like that, it becomes a part of your what you call a memory, permanent memory, let me tell you. Okay. And yeah, since we start from ground up, no student should be worried that I know something previously, I don't know something previously, I was not taking some fun foundation courses previously. All that you need not have to worry, children. Okay. And of course, in the class, you'll be taking running notes. Of course, like I sent you the write-up I sent you today, certain times I'll give you the lesson also in advance. Sometimes I may not give, sometimes I'll be writing here on the screen, and you'll be given enough time to write there. Do you follow?
Yes, sir.
Yes, sir.
Parents are asking many times, sir, what kind of material you give? See, the class notes are dynamic notes in the sense, it's not like I'll write something and print it and give it to you. It develops, evolves according to the feedback from you, according to the traction I get from you. You understand my point?
Yes, sir.
Like you people talk, you people ask questions, it can go in many directions. So that's the reason why I won't print these things and give it to you. And I want this to be an exclusive material for you, not for everybody. Those who attend the classes should be knowing it, right? So you will have to write your running notes along with whatever assignments anyway will be sent through WhatsApp right now. Even class notes sometimes can be sent in advance. Okay, the lesson plan, everything like I was giving you today can also keep coming to you. But ultimately, you have to write your notes. Notes will be a combination of your notes I give you, in the sense what I teach, and how do you personalize it. Do you follow my point? Say I'll give some definition.
Yes, sir.
I will talk something. What is there on the screen or what I speak, you will write. But apart from that, you'll write your own impressions on that. You understand? So you need to personalize your notes like that. Remember, whatever I'm talking now, you will recall sometime later, because this note taking, note making is a great art. All successful people, big people who are in the news all the time, have a common habit. One is they read books. Businessmen, entrepreneurs, right? They have a habit of reading books, and they also have a habit of making notes. Here, most of the notes I'll give you, but definitely for you to read it back, for you to feel that you should go back to your notes, you should personalize them. Really, believe me, those who will follow these things will be really happy later. And what do you have in the notes? Everything. Definitions will be there, derivations will be there, statements will be there, and then and there itself some numerical example to illustrate that idea. Vishnuvardhan, are you listening? And small quizzes to get you interested in the whole thing. Okay, so they'll form our basic body of the lesson. Are you all listening? Mokshagnya, are you there?
Yes, sir.
You have any question to ask?
No, sir.
No. You're following my words?
Yeah, sir.
Right. Now, yes. The notes you take here will form your future reference for all your academic work and exams. You can ask your sisters and brothers. Some of them are here with me. I tell them when we are doing some problem, some formula, they don't recollect. So I tell them all the time, just keep the notes by your side. As we keep doing the problems here in the assignment, if you're not able to recollect a formula, just refer to your notes. So that's what I mean by your future academic work and exams. Of course, before the exams also, you'll go through your own notes. And I made one thing here. In fact, it becomes a textbook in its own right. Yes, I would like to elaborate on this point. Of course, I've mentioned few books to read. H.C. Verma, Resnick and Halliday, and your textbook of 11th and 12th, that is intermediate first and second year. But people still ask, sir, where did you teach this particular thing from? They ask me all the time. Or which book do you follow? As if there's only one book to follow. It's not like following a particular book, believe me. In my 3 decades of teaching, I've followed some thousands of books already. But remember, finally, you synthesize the knowledge. If you ask me a particular point where I picked from, I cannot recollect. Probably I've taken it from some source, and probably I've understood it for myself in some way. Probably one student asked it out, and in trying to clear the doubt, I must have researched. So there's nothing like a single book from which we keep teaching, right? So therefore, it becomes a textbook in itself. Like if you edit it properly for removing grammatical mistakes, and you want to try to make it simple in language and do a little what you call tweaking up, if you do, you can publish it. So that's one thing. Second thing is, many students, my old students, they take these notes to their engineering colleges, because once you go to the undergraduate studies, it's not so much hand holding like it happens at school level here, right? So they have a fixed program. In 1 hour, they should finish so much. They'll finish and go away. And they assume that you know so many things already, right? But supposing somebody did not learn things in a proper way, because he was all the time mugging up, cramming up solutions, problems without really knowing the meaning of it, they have to refer to so many books to get the idea. For you, that's not there. The whole first year engineering will be just the maths and physics we do in the classes here. So many things will keep coming up later, and you'll keep saying, oh, Srikanth sir taught this already to me. Let me go back and refer to my old notes. That happens. Why am I telling you so much? I want you to follow this rules of the game from tomorrow itself. You need to write your notes properly and personalize. I told you, this personalization of notes can be done in various ways, believe me. I need not have to tell you. If you have a habit of writing notes, you can do that. Somebody will use a blue pen, black pen. Somebody will draw some nice pictures which they like related to that. Somebody will write about a joke the teacher played. So there are so many ways of personalizing notes. Okay. Of course, the most important thing here we mentioned, during the lesson, you are encouraged to ask questions and to involve in discussions. This is the most important point. There's a direct correlation between those who speak to me and those who go to IITs. Because why? They are following, and if they did not follow, they'll ask you a question. They'll communicate to you, and while solving problems, we actually solve it together. The students and the teacher will solve it together. So that communication is important, and then questioning is important. And questioning is not so difficult. You know, anything, any new thing you would you would like to make a presentation, you would like to talk to somebody, you remember these questions, try to answer these questions about whatever you talk. Okay, that will become your piece of essay or speech. If you're asked suddenly to talk about something extempore, just keep asking these questions. So what is this? Tell something. How does it happen? Tell something. Why should it happen? Tell something. You need not to say why, what, like this there to others, but within you, you ask answering these questions, that becomes a good piece of communication to others. So in the class, especially when I discuss things, I'll be definitely discussing things from, though I told 0 level, the whole approach is not information oriented. The whole approach is understanding orientation, clarity orientation. Therefore, we talk deep, not superficial. So if you don't ask questions, that gives me brings me a doubt to my mind whether you're following. Otherwise, what happens? You just go on talking. You just may sleep also. Nowadays, online classes, we don't know what will you do there. So we don't have a direct understanding of your work there. So the total time you sit here will be really wasted if you don't involve in the whole process. All right. Now, yes, I'll take a little gap. Ramakrishna Reddy, just read this, what is there on the screen.
After doing the lesson thoroughly, a good number of numericals in the form of exercise problems and trick problems will be done.
Yeah.
Following this, you are
just a minute.
Okay.
We'll do the lesson. You must have already seen SRK sir in the morning was doing element, compound, like that. He was starting from there, isn't it? So in a similar way, even in physics, we'll start from basic definitions, meaning, and here and there some derivations, and then some immediate illustrative examples. That's what you mean by lesson. Later, we'll give some time for only problems. In that, I divide the problems into 2 parts: exercise and problems. Very simple way to differentiate between the difficulty level. This exercise thing, look, you do the repeated things, right? Isn't it? The physical exercise, same steps you keep repeating. See, one of you please close your that one audio, mute it, because the TV thing is coming up here. Ramakrishna, whoever it is. So exercise will be simple. It's like bringing a formula and substitution. That will be something like exercise problems. It won't be that difficult, of course. It's a simple word problem, which you've been doing in arithmetic in the schools. There will be a word problem in which certain physical quantities will be given. And if you recollect some formula, you can somehow fix it. And sometimes the idea may be not so easy to grasp, but still with a little effort, you'll understand it, and 1 or 2 formulas use and solve the simultaneous equations to get the answer and over. But problems are going to be not like that. In terms of the meaning, in terms of the setting of the question, in terms of bringing all the ideas into action to do the problems, that will be really a problem only. So we'll divide the whole thing into exercise and problems. Here, this is outward exercise, but this is the mind exercise is required so much for problems, children. Okay. Then after that, what is it, Ramakrishna?
Following this, you are provided with assessments in the form of multiple choice questions. In the form of multiple choice questions,
both multiple choice questions will be single multiple choice and multiple selection. Okay.
Based and integer
comprehension based passages.
Yes.
And then integer type
questions.
So these are all the types of questions which are actually asked in IIT-JEE Advanced, but let us not think about that for a while. These are all problem solving. You have to select from 4 answers, 1 answer. You may select 2 or 3 answers from 4 answers. You may have a passage there and then 1, 2, 3 questions. You will have a numerical problem where the ultimate answer should be brought into numbers. So all this kind of exercise will be done. But of course, later, this one, Ramakrishna.
You will be given reasonable time to solve these assessments. Doubts will be discussed later in the class.
So close your audio. Actually, when you are in the class, ask your people to give you that free the room for you only, huh, Ramakrishna? Right.
Sir?
No, actually, when you are in the class, see that your surroundings are sound free.
Okay, sir.
Right. Now, of course, to impress you people, we don't say, come on, this 100 problems do in 1 day or 1.5 days. No, we'll give you a reasonable time. Will be very reasonable, because you'll be doing maths, physics, chemistry, right? So in 3 subjects, you'll be getting assignments. So it'll be very reasonable with you. Maybe we'll give you some 20 questions, which you have to solve in 1 hour or 2 hours, not more than that, and given an assignment. Or even if 60 questions is given, that will be, for that we'll give you 3 days to solve. But remember, solve the assignment on your own to the extent possible, whether it is half of it you try or 1/3 of it you try, whole you try. But doing that is very, very important. You cannot simply throw the assignment away and say that daddy, there's no work. And your daddy will come and ask me, sir, you're not giving work. If you give work, my son will do, or my daughter will do. So we should not get into that kind of a game. You are doing it because you wanted to do it, not that me or your father should or mother should force you to do anything. Okay. Right. Now, yes. Suhita, read the first thing.
In the addition to these assignments, you will be asked to solve problems from H.C. Verma's concept of.
Yes. So I want you to buy this book. A hard copy is around 200 plus rupees. Better have it. But soft copies we are used to, I have no problem, because that's available everywhere. Okay, but probably looking at the screen, people feel is not so good. So we have to have a hard copy of this H.C. Verma part 1 right now. Okay. While doing my problems in the lesson, I may ask you to open H.C. Verma and point out at a particular problem, children. Do you follow? Huh? Persist.
Yes, sir. Yeah.
Do you have this book with you?
Yes, sir. I do.
Okay. So directly, sometimes instead of giving a problem of my own, I may ask you to just open H.C. Verma page number 33 and question number 2 or 3. You should be in a position to open it and then do it. Okay.
Sure, sir.
Yeah. So I won't trouble you with Iridov right now. There's a book called Problems in General Physics by I.E. Iridov. That's the best book possible for IIT-JEE. Actually, I don't want to use the word IIT-JEE, remember it, because you do solve the problems and you write many exams. By doing such good, tricky problems, your understanding of the subject will be very good, and ultimately you'll become a good problem solver. Whether you go to IIT is not is so important, believe me. If you go, well and good. If you don't go, you'll go to something lesser than that, but still better. Okay. But that culture of problem solving, which is very, very important. Don't you think, like now this COVID situation you've seen as youngsters, I don't know how you analyze, but as a government and as a state, we failed in solving the problem of COVID. Not that suddenly you will discover scientifically something to attack COVID, but the crisis management was bad. Okay, so this kind of problem solving at an young age actually helps you to become a good problem solver even in future. So why am I focusing so much on the whole process? Do you know? That's what is missing nowadays in schools and colleges and in children and parents and teachers. That's where unnecessary pressure comes. And naturally, you now right now you don't realize, but exams approach, you'll be coming under pressure because somebody else is doing well, somebody else is getting marks, and somebody has gone to IIT already, have to go to IIT. So, but that will be too late. Good students plan in advance. Like good governments plan in advance. I don't know whether you understand the meaning of it.
Yes.
You're always wondering why second wave is not happening in India. And everybody was cool. Oh, come on, we Indians are something special. So second wave, nothing comes to us, and suddenly we are in trouble now. So this planning ahead is very, very important, children. And that kind of habits automatically come to you once you get into some serious problem solving. And I want you to start from today itself. You are planning whatever, sir. See, we have given you some gap in between the classes, and sirs will be giving you some smaller level assignments now. Just finish it off, okay, and be ready for the next day. Of course, remember, physics is a wonderful subject. Be open-minded. What do I mean by be open-minded? There are a few things like this. Some students have a habit of reading popular physics books, and they talk only what you call ideas. They like ideas, but they don't know how to apply it because their math is weak. So once and they'll be closed. They'll think that, okay, physics is only talking but not doing. But somebody is good at math, they somehow logically connect, but they don't want the feel of physics. And they don't want to take the other part of physics. Physics is both, remember, the experiment plus maths. You know, the physical system behaving in a particular way, and plus maths. So somebody may be liking this, somebody may be liking that, and somebody may be close to the other one. So that being close to a particular idea of physics or particular way of doing physics is not good. That's what I mean by open-minded. Every word is used with a purpose here. Like somebody says talks physics talking doesn't work. You should work out problems in physics. Somebody remembers formulas and somehow fixes problems, but do not know what is he doing or what is she doing. Those students can do lower level sums with some logic, but cannot do high level sums because the physics part will be troubling. So the two aspects of physics, the feel and the expression. The feel is the experimental visualization of the problem there, and the mathematical approach to it, both must be considered and both must be cultivated. Emmanuel, do you follow what I speak?
Yes, sir.
And if you do that, of course, you'll like physics and you'll remember this experience and recollect this experience forever in your future studies later. All right. Now, this is now more details, the nitty-gritty of things, more details of it. So I'll be covering mechanics, heat and thermodynamics, properties of matter and fluid mechanics. This is what you call the 11th syllabus or the intermediate first year, whichever you call it, depending on your board. Okay. Don't ever think, array only 3 topics for the full year. Remember, you already have seen, I've sent you the write-up. In mechanics itself, they've got many subunits. This forms more than 60% of the total syllabus. And more of that will come anyway, I'll talk. Okay. So this is our unit-wise division of topics. Okay. Then, yes. Mechanics is the main unit, major unit. Mechanics is at the heart of the whole physics. If you think this all the body of physics all around it, From here flows blood to all parts of the other branches of physics. That's the importance of mechanics, children. Okay. Most of the main principles of physics take their roots in mechanics. On the previous slide, I showed you something here. What is this? This is Newton, and this is the Principia, in short, mathematical principles of natural philosophy. This is the beginning of what we call as physics today. Previously, many scientists talked about physics, many philosophers talked about physics, even Aristotle talked about physics, but the physics we do today is something special. This is a culture started by Newton, who believed that physics laws or physics has to be expressed in mathematical form. And that's where a scientific method of doing nature started, studying nature started. So all those principles he laid down, many important principles he laid down in this book called Principia. And there, mechanics is the one which started. He started because mechanics is easy to deal with. Like when I hold this phone, can you see me? Huh?
Yes, sir.
If I asked you why this phone is at rest, or if you ask this this to your grandmother, for example, who did not study science or not much of education, she might say, you are holding it, that's why it's not falling down. But as a physics student, you will say, no, there is one weight of it acting down. My hand is applying one more force called N. Since these two forces are balanced, this is at rest, I'll say. But if I drop it, it falls because you say, when I hold it, my friction between the fingers is holding the phone against the weight. But once I remove this friction between my fingers and the phone, it is coming down because of the acceleration produced by Earth's force, you say. So this kind of, and you'll write the equations for that. That's what you mean by expressing natural events in mathematical form. So expressing natural events in the mathematical form is physics, children, finally. And the main principles all started in what we call mechanics. What are the main laws? You tell me. See, this particular paragraph which I mentioned here is one of the most important paragraphs for us for future physics classes. Was just read.
Yes, sir. Mechanics consists of Newton's laws, the concepts of force and torque, principles of conservation of linear momentum, energy and angular momentum are framed here, and their utility along with the idea of reference frame in solving problems is illustrated.
You understand the meaning of it? In just one paragraph, I gave you the summary of the whole mechanics and as well the whole 11th and 12th physics. In every aspect of our discussion, this Newton's laws keep coming. You learn Newton's laws here, but you'll apply for molecules of an ideal gas, and we applied for an electron when it is moving through a wire to form current, and we applied for an electron which is going around a nucleus. So these Newton's laws will come everywhere. Torque, of course, this is also important. This Newton's laws talk about only translatory motion, that is for a particle they are applied, and they're applicable when the particle moves in a straight line or the particle moves in a curved line. But when a particle spins or when a body spins, we require what we call torque. So these two dynamics ideas, force and torque, then three conservation laws or two more conservation laws will bring conservation of linear momentum, energy, and angular momentum. In mechanics we learn, and later we include conservation of charge. Okay. With that fourth conservation law, we cover the whole syllabus of 11th and 12th. Of course, all this with the idea of reference frame, that where do you do the problem from? Because motion and rest are relative terms. You must have heard these words many times by now. I'll keep talking about them. again and again. So a physics problem is not done on the board, is not done on the paper, though literally you write it on the paper. In fact, you will be doing in some or the other reference frame. Okay, so the reference frame idea, force, torque, conservation laws, this form the whole of our physics. And I'll show you how a physics problem can be done from these basic rules. So that way physics is easy, not difficult. But it's also difficult if you don't have that culture of doing things from basic. Okay, what I was trying to tell you was, there's not much to remember blindly. There's not much to mug up in physics. There are very few number of principles, and how to apply these few principles to a very wide variety of physical situations, or wide variety of physical experiments, or wide variety of physics problems, as we call, is actually the good and bad about learning physics. Good because that's what is required. Bad because that may look difficult for the exams. Okay, so yeah, the whole philosophy of teaching should be like that. And my philosophy is very much this, that how to work from fundamentals. And these words you keep hearing again and again in future. You know, Elon Musk is a famous entrepreneur, you know, don't you? Anybody knows about Elon
Yes,
Musk?
sir. Yes,
Yes,
sir. Yes, sir.
At least you know he's having these Tesla cars successfully running on the roads, right?
yes,
Hmm? And many other things, Hyperloop and SpaceX. These are the companies he started. You know, you see his initial.
PayPal also, sir.
Huh?
PayPal.
I'm not able to hear you, but he also started a thing called Neuralink or something
Pay-
like that, right?
Yes, sir.
Yes. But what is his specialty? He did so much. How, you know, his basic idea is to work from fundamentals. His basic idea is to work from fundamentals. Just watch his video somewhere. Of course, don't imitate his bad habits. But that fellow is something special as far as his belief on fundamentals and how to grow from fundamentals, how to make it a big business from the idea of fundamentals is something very special with that fellow. Okay, that standing apart, what I was trying to tell you was this: physics, especially, even other subjects also similar, but definitely for the exams that may be difficult. Chemistry, of course, it is somewhat, you need to remember some information as well, inorganic chemistry and all that. In mathematics, the challenge may be to catch a particular elegant way of doing a problem, because there are many ways of doing that particular problem. But in physics, there are not many ways, believe me, because whatever way you tell, I'll tell you from where is the root of it. The physics challenge is this: how to apply some main principles of nature, important principles of nature, to a wide variety of problems. And that will be really, if you get into that habit of doing it, you will become a leader in the industry later. Because what does leaders do? They troubleshoot, not that everyday work they do. Not that you need to learn a particular coding also. Coding somebody will do for you. But are you in a position to what you call frame algorithms, go to the basic, and then set up the problem for people? So that comes from your understanding of the fundamentals, understanding of the basics, or not elementary things, children. Basics or fundamentals or concepts, you can use them interchangeably. Okay, in applying these grand ideas means main concepts. I stopped using the word concept because it's misused. Grand idea is this: what? Energy conservation. Principle of momentum conservation is a grand idea. To just state, I can tell you something, but anyway, a lot of it we'll be doing in future. But think about my words. Okay. So in applying these grand ideas to a variety of problems, the student is initiated in a culture of working from fundamentals. This is going to be very, very important. If you want to start a business of your own, if you want to start an enterprise of your own, you cannot start it because somebody else is starting, or that is now the buzzword. You need to really know You need to really identify a particular problem which is troubling people and find out a solution for that. Then that becomes slowly an enterprise. So remember, physics is such a great subject. Of course, many sciences are like that. You learn one science thoroughly, you learn other sciences easily. But physics is something special. It is both maths and the physics. That's the reason why physics has such a beautiful, what you call, arena later to work with. Okay. Now, yeah, the subunits in mechanics. Because I'm going to put lessons here, lesson 1, lesson 2, lesson 3, I made them subunits. So tomorrow, of course, we'll start this mathematics for physics. That will have some lessons. For example, quadratic equations. Some small introduction about functions. And then derivatives, integrals, like that. And then vectors. So like this, individual lessons will be there under each heading here. So that we've got 10 main units, subunits. Mathematical physics, kinematics of particle, Newton's laws. In kinematics of particle, once again, there will be some 10 to 11 lessons, children. Okay. In Newton's laws, once again, 6 to 7 lessons. Like that, each will have some, on the average, say for example, 7 to 8. 7, let me say, 7 into 10, 70 lessons. This will be 70 days or something like that. Yes. So this is what you mean by this taking some 60% of the total 11th class or first year syllabus. Okay. And of course, when I ask you back, you need to give me the headings for the lessons when I start a new unit anytime. And this has got 7. The concept of temperature, zeroth law of thermodynamics, thermometry, which you know somewhat, solids and liquids expansion, gas laws and gas expansion of gases like Boyle's law, Charles' law, ideal gas equation, like that. And kinetic theory of gases, applying Newton's laws to gas molecules and trying to understand how pressure comes, how temperature comes. And energy conservation here in the form of first law of thermodynamics. And second law of thermodynamics also is there. There are some topics for mains, there are some topics for advanced that I'll separate later. And transmission of heat, conduction, convection, radiation, all that. So all this comes under our present syllabus only. Okay. And then Young's modulus, bulk modulus, shear modulus there. Archimedes principle here, Bernoulli's principle here, and surface tension, very puzzling aspect of fluid mechanics. And then fluid friction. Viscosity means friction in fluids. There will be friction, solid friction in Newton's laws of motion here. When you go here, friction is a particular special heading, which is a challenging topic. But here, solid friction, basically, not fluid friction. But here, we talk about fluid friction, that is friction between different layers of fluid. Fluid means liquid or gas, or friction between a solid and fluid. Of course, these lessons are small lessons. You do not have to bother. They'll come at the end of the year. Like, yes, each subunit is organized into many lessons of appropriate length, and both in terms of the number of periods we take and also the content we take in that. And same kind of structure and function will be there for 12th class syllabus. There you get waves, electricity, static electricity, current electricity, electromagnetic induction, magnetic fields, modern physics, all that will come in 12th syllabus. Okay, but like I told you, mathematical physics, when I do, I'll give you all that subheadings tomorrow itself for that unit. Okay, children. And as I told you, intermediate students should take this Telugu Academy book, and as well they can buy NCERT also. And CBSE students should take this NCERT book 1, book 2, book 3, whatever they have. I think they've got these 2 books in 3 parts now. Book 1 is separate, book 2 is divided into 1 and 2, I think, nowadays. And this has to be there, part 1 and 2. 2 you'll take up later. This book I want you to buy if it is not there, or you can have a soft copy also. And this is a problem book right now. Also, if you have, that's good, because on and off I may suggest it. But soon, in a month or 2, you can buy that. And depending on your response, I'll suggest many problems books. There are so many actually speaking, but there's nothing like collecting all the books and keeping it with you. As we keep doing things, I keep suggesting more books and more work for you people. So this is all the nitty gritty, the details of what you do throughout the year. Children, now tell me, any questions asked? Is there any clarity to your thought process as to how to do physics? That's very, very important. Whenever you start a work, you should know what you are up to. Many times students don't know. I have not talked about the prospects of you people for different institutions. That will be done separately once all the students come in. But right now, how to do physics for 11th class? That was my goal for today's lesson. Have you understood the things? Any questions you have?
Yes, sir.
Tell me now. Any questions now?
No, sir.
Sir,
Sure.
I have a doubt,
Yes.
sir.
Yeah, please.
Sir, in this Telugu academic and NCERT book, sir, which one should we buy, sir? I already have
You are
Telugu
from CBSE, no?
Yes, sir.
Buy only this, because this same books they are actually. Small changes are there for maths here. In fact, they copied this NCERT for intermediate actually.
Okay, sir. Yes,
So
sir.
Telugu Academy doesn't mean Telugu book, that's English book only,
Yes,
but Telugu Academy publishes that.
Okay.
Okay. And intermediate students take only this Telugu Academy books, and if you can also have these books, it's okay. Especially for chemistry, the exercise is something good in NCERT. In the intermediate book, they remove that exercise in chemistry. But physics doesn't matter. And
for H.C. Verma book, should we buy the 2 parts or only first part?
Right now, first part is enough. Slowly, you can take second. Okay. Because first part itself is quite big. Okay. So, no, any other questions, children, about books or whatever you have? You tell me. Because I'll start the lesson, mathematical physics, tomorrow. Yes. Mochagnya, Vasist, Emmanuel, Lakshya.
Sir, I have a doubt, sir.
Suhita, Vishnuvardhan. Yes, tell me.
Sir, like you told, you'll provide the notes, no, sir. Should we include the notes with the R running notes? Can we include it?
Can you include means you can write there, no? You can take a print and put it there. You can write them again. That's FT.
Okay, sir.
But yeah, I forgot to mention. I mentioned it in your write-up I sent you. I want you to have one nice long pages, white pages notebook. White pages I prefer because the diagrams will be there. If you're having a habit of ruled thing, just forget it for a while. Long notebooks, and better bound things I want, because I want that book to be there for you anytime I ask you for referring. And you can take Classmate or whatever, some nice books are there, no? Notebooks. Classmate is one, and then I don't remember the another one. What is the other one? The branded books. No, I'll ask you to show your notes also. I don't want you to write into some silly that brown rough books. Do you follow? Ramakrishna, Mochagnya, Vishnuvardhan. Tomorrow you ask your father or mother to get it for you, or you go and get it in a stationery shop nearby before 10 o'clock. Okay? Or before 9 o'clock. We have got class from 9 to 10. So some nice notebook I want you to have. Do you follow? Because I'll be asking you to show it on the video here.
Yes, sir.
Yes.
And Sai Ganesh, are you there, child? Okay.
Yes, sir. Yes, sir.
Okay. Right. So any questions to be asked? If there are no questions, I'll stop for today. All right. Thank you, children. We'll meet again tomorrow.
Okay, sir.
Bye.
Sure, sir.
I'll be
Thank you, sir.
ending the session. Thank you.